Here was to simplify the following, and there are 4 different square roots here, and I want to simplify them by using prime factorization, meaning I'm going to factor each of the numbers inside the square root, pull out any of the pairs that I can find with the prime numbers that I get to. So in this one here, 60, I'm going to break down these one at a time. So 60 becomes 6 times 10. Then I can break down 6 into 2 times 3. I can break down 10 into 5 and 2. And now, anytime I find a pair, because I'm taking the square root, I'm taking out one of these outside of the radical. Whatever is left, in this case a 3 and a 5, I have to multiply back together and it stays on the inside here because those can't be broken down anymore and I got no pairs. So for the square root of 60, simplified, is 2 root 15. Now the second one, 150 here, I'll split into 15 and 10. And that splits into 3 and 5. This splits into 5 and 2. Looks like I have a pair of 5s, so I'm going to pull out a 5. And then the 3 and the 2 are going to stay on the inside, and I got to multiply those back together to get 5 root 6. Now for the third one here, 128. So 128, I can divide, let's just say divide by 2 here, and that gives us 64. And now I can simplify that to 8 times 8. I could continue simplifying into 2 times 4 and 2 times 2 for that, but really what I can do here is I can actually pause and just take this here as my pair, and then this here is left over since the last one. Either way, I'm gonna get the same answer, right? So this here would give me 8 root 2. If I were to go back and walk through it individually, I'd get 4 and 2, 4 and 2. These would break up into 2 and 2, 2 and 2. I'd have a pair of 2s, a pair of 2s, and a pair of 2s. Then when I pull that out, I get 2 times 2 times 2 on the outside with 2 on the inside. 2 times 2 is 8. So either way, you'll see that I get the same answer. Now, the last one here, I got 200. I'm going to split this into 2 times 100. And the same thing here, I can split this into 10 and 10. And there's my pair. And what's left over is 2. So I end up getting 10 root 2. Now, this isn't prime factorization. It's really just seeing the perfect square here and pulling out that 10. But if you feel more comfortable, you can always break it down into its final prime numbers. I see a pair of 5s here, which I would pull out, a pair of 2s here, which I would pull out, and what's left over is that single 2, which again gets me my final answer of 10 root 2.